Alright guys, today's goal, the learner will understand how to find the probability of compound events. A compound event combines two or more events using and or the word or. For instance, suppose you roll a number cube. So here's an example. Mutually exclusive is one type. Event A, you roll a 3. Event B, you roll an even number. Is it possible that 3 is an even number? No. So they are mutually exclusive. Okay? So the probability of 3 or even, well, the probability of being 3 is 1/6. The probability of being even is 3/6. Add them together. So if you can say the probability of A or B, and they are mutually exclusive, meaning they are not the same thing, you just add them together. Now, overlapping events. Event A, you roll an odd number. Event B, you roll a prime number. Well, 3 and 5 are both odd and prime. That's why they're overlapping. So this time you do the probability of A. What's the probability they're odd? Well, we have 3 out of the 6. 1, 3, and 5. What's the probability of being a prime number? Well, you have 2, 3, and 5. That's 3/6. How many of them overlap? 2. Subtract out 2. So you would get so this total here would be 2/3. Here it would be 4/6, which is also 2/3. They happen to be the same. That doesn't always happen, but so let's look at the first problem here. You roll a number cube. Find the probability of rolling a 2 or a 5. Would that be mutually exclusive or overlapping? Well, it would be mutually exclusive. So the probability of 2 or 5. 1/6 plus 1/6 is 2/6, which is 1/3. Okay? Next problem. You roll a number cube. Find the probability you roll a number less than 4 or an odd number. So less than 4. 1, 2, 3. So probability less than 4 or odd equals, well, the probability of event A, less than 4. Well, I have 3 of them. The probability of an odd number, well, there's 3 odd numbers, so 3/6. Do I have any numbers that are both odd and less than 4? Yes, I have 2. So I have to subtract those 2. So that would be 4/6, which is 2/3. Okay? So when they overlap, you have to subtract what happens twice. Okay? Now, independent and dependent. 2 events are independent events if the occurrence of one event has no effect on the occurrence of the other event. Flipping a coin twice. Does flipping it once have any effect on the other? No. 2 events are dependent if the occurrence of one event affects the occurrence of the other. So let's take a look. See in here how we have these marbles. We have 1, 2, 3, 4 green, 2 red, 1 blue. The probability of a green and a blue with replacement. That's why it's independent. Well, what's the probability that I select a green? It's 4 out of 7. I put them all back in. What's the probability I select a blue? 1 out of 7, multiply. So if they're independent, probability of A and B is probability of A times the probability of B. Now without replacement, it's probability of A times the probability of B given that A happened. So probability of green and blue without replacement. So I reach in, I pull out, it's green. So now how many marbles are left? 6. How many of them are blue? 1. So 1/6. So 4/7 times 1/6. Okay? So let's give these a try. Alright. A bag contains 4 red, 5 green, and 2 blue. Okay, so I know that I have 11 total. You randomly draw 2 marbles, one at a time. Find the probability both are red. So you replace the first marble. That means independent. So we're looking at this. Probability of red and red. Well, the probability of getting a red, I have 4 out of 11 times 4 out of 11. So 16 over 121. I do not replace the first marble. So now I have, so again, the probability of red and red is still 4/11 of the first, but now I pulled a red. So I have 3 red left and only 10 marbles left. So 12 over 110, which is 6 over 55. Okay? So there's the difference between an and an or. An or we add and we multiply. And you have to remember the difference between mutually exclusive and overlapping and independent and dependent. Okay? So go ahead, read this question, bring it back tomorrow. See you guys then.